wireless connection? I haven't figured that one out.
I don't think we will need wireless connection. I have a thumb drive, and all the exercises, everything is, I can just copy it over.
Okay.
So I'm prepared for this kind of situation.
Bundle.
So let's view.
Our spec isn't part of the project, so we can just say.
This is very slideshow. That's not what I want. Because my background is, I come from when this TDD thing movement came around, right? You had this one UML thing going on.
Mm-hmm.
I was into that branch actually. Bubbles don't crash. You make all those pictures using all the modeling tools and stuff, but you need to start writing codes, right?
Mm-hmm.
You do a lot of upfront design in that case, right? The good news is, TDD is basically a design activity. And everything that you learn, the basics of object-oriented design principles, it's applicable while you're doing the TDD. Let's see if I can get this keynote. Oops. Oh yeah, it's going here. And Ken has some donuts and stuff, if you, it's just outside, and if you want to grab something, you can grab it while I set this thing up. So I'm just going to start the presentation right now. There are 3 learning levels. So everybody can see this, right? Sorry, I couldn't find the projector. So the first level is, you just copy the actions of someone else blindly. using simple rules, and you don't really know that there are benefits to doing it, right? And the second one level is like you understand why you're doing the things you're doing, why do they make sense? And the third level is when you start to improvise. You know, all this TDD, BDD argument. The goal of TDD is basically, you know, is specification, not validation. It's not the verification. Ken Beck says, you know, it's just correctness of the code is a side effect. So you specify the behavior of the system. And one of the small problems, like which was involving a triangle, Ken Beck wrote like 8 or 10 tests, whereas Robert Binder, a guy who does testing, is a QA guy, he did 65 tests, right? So he just stopped after writing 8 tests. Why? Because writing the test is a way to drive the design of your code. And it just happens that correctness of code is a side effect. Okay? And next to the 4 fluency levels in TDD, you might actually recognize, okay, as you go through different phases, which fluency level you are, based on what your focus is. The first level is you're the Tarzan at TDD, where your focus is only on the code. Okay, you can write unit tests, but the problem is the unit test will only work on your machine. When you put into a, some other continuous integration server, things might break because you have dependencies. Second level is where you are focused on the code coverage. You can do red, green, refactor cycle and all that. You are aware of it. Your code can work consistently on the continuous integration server. It doesn't have any dependencies. And the third level is your focus has changed from code coverage. Code coverage, at the second level, code coverage, there are a lot of people who are so totally obsessed with code coverage. 100% code coverage doesn't mean anything, especially if it's like C0 coverage, right? You seem to be nodding, yeah. So my manager was so focused, if it goes, the coverage, code coverage goes below 80%, he wants to even, fail the bill, basically. It just is line-based coverage. It doesn't say much about the quality of your code, either the production code or the quality of your test code. Okay, and that's where the third level you are focused on maintainability. How good is your production code? Where you have several different metrics. Like if you have used metric foo or something, it gives you all different metrics like cyclomatic, code complexity, and all the different things. How well can you maintain this thing? How well can you extend this system? And the last level is, the fourth level is, your focus is now on the design. You really know the main purpose of TDD is basically the design of the system. It's not the maintainability, it's not the code coverage, it's not, design actually is the primary motive for this entire thing, right? When you do the TDD, you basically end up with a minimal system, right? Like initially I said, this is very similar to what I said before. Everything boils down to zeros and ones. The progression of a Lisp programmer, the newbie realizes the difference between code and data is trivial. Expert realizes that all code is data. And the true master realizes that all data is code, right? So when I read through the Ken Beck's book on this TDD, a lot of things he does, it's very intuitive to him, but people at different, TDD, experience will find it difficult actually to come up with that kind of an intuition, because they can recognize this. Everybody can recognize code duplication, right? Everybody in this room can recognize code duplication, 100%, right? Yeah. But when I saw Ken Beck coding, I realized he actually looks at the data duplication, and he actually applies very advanced design principles to abstract things out from the code. So he's able to use TDD to drive the design of the code. But it's very difficult unless you consciously know what principles are you applying and you apply them to your code. It's very difficult to do the TDD to drive the design. That's where some of the difficulty arises. And that I've been going around, everyone asking how comfortable are you with TDD, or what are your thoughts about what makes it difficult. This is one of the things that makes it difficult, actually. And I also say the main goal. Once you know what the main goal is, it's specification. Forget about the validation. It's not the validation. It's not like, okay, how many tests do I really need to have? Should I have like 100% code coverage? Do you need to have all different combinations of inputs and outputs and test this thing exhaustively? When do I stop, basically, right?
Mm-hmm.
That's one of the questions. How many tests should I really write for this thing? And the answer to that question is, you write tests when the fear becomes boredom.
When the fear becomes boredom.
Fear becomes boredom, basically. You're afraid of your code, but your confidence in your code, as it becomes higher, if your confidence is low, then you need more tests.
Okay.
How likely something is supposed to happen versus, it's kind of like a safety net. And if the holes in the safety net is bigger,
Mm-hmm.
obviously things are going to slip through. Okay? And let's look at this. This is the basic structure of any test. It's called as 3 A's. The first A is the arrange. You create some objects. Okay? That's the first step. Second is you act on them. You stimulate them. You send a message. You do something to the system. And the third is you do the assert. You check the results, right? When you're writing a test, one of the difficult things is like some people have found, what do I check for? How do I test this thing, Let's say you don't write any tests. How are you doing the programming? You're looking at the output. And you're manually verifying something. Oh, I got the result, adding 5 plus 5, I'm getting 10. You're manually checking the output, right? The assertion, the third step, that automates that particular step. So it becomes an automated way of verifying the behavior of the system. Okay? I will actually go through this thing again at the canonical test structure and go through each phase, how it relates to the entire process, okay? So the TDD cycle is you have a failing test. You start off with a failing test, you make the test pass, and then you refactor. Okay, if you see that it's red, right? Red is when something goes red, I mean it's a failing for the right reason. Why should we actually have a failing test?
Well, you want to see if your code change. I mean, if it fails up front, then when your code changes, then you know that it changed for the right reason.
Yes. So if I want to say it in another way, the test does not have another test to prove its correctness.
Right.
So the only way I can know the test is actually testing the thing that I am assuming is testing, it's failing for the right reason. Okay? And if it fails for the right reason, then I know, okay, if I give you a problem, let's say adding 2 numbers, and I write a test which says 5 plus 5 equals 11, that's a failing test. Is that a good failing test? It's not failing for the right reason. It actually violates the semantics of what you're testing, right? If the 5 plus 5 fails because the interface doesn't exist, then it's failing for the right reason. Okay? So you write a failing test, you are green, and then your goals should be to go to green very quickly, actually. Usually the 1 to 5 minutes. Within 1 to 5 minutes, you need to get to green very quickly. In this first step of the phase, you're allowed to commit any kind of sins, actually. Very nasty code, duplicated, you can do anything you want to get to green very quickly. Okay, that's the phase 1. Going from the write a failing test to make the test pass. This one you commit a sin. Your only focus is to optimize the time between this thing, minimize the time between this thing, okay? And then at this phase, your focus is only on getting something working immediately. Your focus is only on that particular aspect, solving the problem. Okay, this works. I know this works. That problem is solved here. And this stage here is where you solve the problem of clean code. Clean code of your production code as well as the test code. If you see these 2 colors, they are green. You start off green, and when you end the refactor, you end up green. Okay? If something changes the color, then you have done something wrong, okay? And then you write a new failing test, and then this cycle keeps going on. And Mark mentioned something about the diagnostics. So that also has been added. When you write a test, there is one more step you can add in here. Make the diagnostics clear just for yourself, or other developers who will be maintaining it up to you, move on to better things. So this is where you make the this expected output, this is the actual output, and this is where it failed. You exactly know where to look for and how to fix things. Otherwise, there is no point in writing the test. Failing test should actually localize the defect, and you should be able to immediately go and fix the problem. That's the value in having a test, right? So let's just see how I showed you that looping cycle, but this is basically a traffic light. And all the valid transitions is how you need to actually code and be aware when you make the transition. You will see what the blinking lights are and what the transition, all the related transitions are, and how it relates to when you actually code, okay? So for those who have never seen a traffic light, so this shows you green, you go from green to yellow to red, back to green again, yellow, red. So this sequence is a valid sequence. When you're doing programming, you start off, when you don't have anything, you're green, you write something, it goes yellow. Yellow means you maybe made a syntax error. It's a compilation error. You didn't do a require spec helper. You didn't have the configuration, like one of the problems that you said you were having was configuring things. You are in that yellow state, basically. Once you fix those things, and it goes red, that's when it's failing for the right reason. The test is actually testing something, you are assuming, okay, this is testing this particular thing. From red, it goes to green, okay? So this is the transition we just saw. This is the traffic light sequence, how it goes. These are all the traffic transitions. Okay, these are all the three possibilities. Going from green to yellow, you made a syntax error, you corrected, you failed for the right reason, and you make the test pass. You write the production code, just the minimal amount of code to get to green quickly, okay? So this is fine, these are all legal transitions, okay? Now let's look at the blinking scenario, where you're green and you're green, you did something to the production code, you're green, you wrote another test, it's still green, it's blinking green. Okay, can you think what's going on here and what we should do? You might have already
I would think you need to write a new test because you're not, your perceived problem isn't supported by the test data that you're injecting into the situation. So we believe that this environment that we're going to set up is a problem. If it stays green and passes the test, then whatever I've assumed was the problem isn't the problem.
One of the reasons could be the feature is already there. Okay, for instance, let's take a simpler scenario where you're solving a problem, but it was so obvious. I gave you a factorial problem and you typed in the abstract solution the very first time. And you write a test which actually exercises abstract solution, and then you cast the boundary conditions, the edge cases. Mm-hmm. When you add those tests, the abstract solution handles that cases as well. So when you add new tests, it's still green. Okay? So it's still passing because the system actually already satisfies the behavior that you expect in the edge cases. But how do you know your test, since your test doesn't have a test to prove it correctness, how would you know this is actually happening because of the edge case? Or maybe it's because something else. Maybe your test, how do you know the test does not have a bug? If it's green, red, that's why
you would have to modify your code to go back to
exactly. Red. You modify your production code. For the edge case, you could just a short circuit and return an unexpected value. Make the test fail. Then I know, okay, it did happen because of the edge case. Now you went red, and then you can go back to green again. Okay? So this happens when you're actually faced with a situation where you go into a project, it does not have any tests, it's a legacy system, you want to add tests.
Okay.
You have to go and mutate the code to make it fail because the code already exists. And this is one of the problems you have when you have a test lab situation, right? Because you may have to comment out the code, or you may have to mutate the code, change the if-else condition, and make it return true or false. You have to mutate the code based on what you're testing. Okay. So we saw this situation going green to green. So when something is blinking and it's green is blinking, stop and think. You need to do something. You want to make it go red and then go back to green.
Okay.
Next is now, what is this blinking yellow? We saw it blinking green. What does yellow mean, first of all?
So you said some sort of compilation
It
configuration.
could be syntax error, like configuration is not done. Those things you still have to fix them, right? So you still have to fix it so that you still have work to do there. Blinking yellow means you can't proceed further. Fix your syntax error, fix your configuration, and you can go to the next stage, which is red.
How are you recording the results of your tests overall? Are you commenting them into the code, or are you keeping them on a separate book, or how are you doing that?
See, if I'm writing a code for which I'm writing from scratch, I would just comment out the code because I am more intimate with the code.
Well, I would think that's a lot easier.
But if it's a legacy code, it's very difficult actually. It depends on the situation. I can't give you just like the generalized statement. Like, you know how Heckle works?
More than 5 years old?
Legacy, for my purpose, legacy, I consider anything that does not have tests as legacy system, okay? Probably some of you here might have used Heckle code mutation tool, right? So, okay, look it up. Basically, Ryan Davis wrote a gem, and if you already have tests, let's say you have a coverage of 80%, you run Heckle on it, it runs and mutates your code. See, I know my tests are valid. If I break my code, the corresponding test which is testing for something should break.
Mm-hmm.
It should break for the right reason, it should pass for the right reason. That's how I know it's working. And you do it once manually, because we don't have a test for our test to prove its correctness, right? So we already saw going from yellow to yellow. And what does this blinking red mean?
Code's not behaving the way the test is coded to expect it to behave.
You're not finished. It's past when it should have failed.
No, it's still failing.
Still
Either
failing.
the test
It's still
is bad
failing.
or the code is bad.
Still have some bugs.
Yes, it's failing, and this thing happens when you have some dependency on maybe you have data dependency. Context is like your test is too big. There is test dependency and test data pollution that could happen because of that. Another reason is you're upgrading your framework, either you're upgrading your RSpec or a Rails or something. It's a major upgrade is going on. And it takes like an hour, 2 hours to actually like refactor everything right to the new method and all that stuff. So you will stay, those are exceptions actually. So you focus mainly on getting from red to green very quickly. The exception is doing an upgrade, so you can't avoid them. So, but you still need to stop. If you're not doing a major upgrade, and if you're flashing like this, it also means your test is too large, basically. Okay, you're testing too many things at once. You need to test one thing at a time. Take smaller steps. That's the feedback mechanism you're getting when you're having this red things. You're not progressing, basically. Have you ever had the feeling of, when you're driving, all the lights are green, you're just driving and, oh, green, 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 and you hit the highway and you keep going?
Mm-hmm.
Right? That is the next thing, actually. This is the opposite of that. The next thing is like, that's what we saw initially, green, 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 green. You refactor the code, you actually refactor the test code, it's green, green, green. You refactor a lot of tests, you have like 5, 10 suite of tests. Now we see a lot of duplication emerging. you abstract away all this duplication, everything is green. Okay, you're cleaning up the test code. You could also be cleaning up the production code as well, and you're like green, okay? So we have covered all the blinks. Let's now look at the other variation actually. So this is not really going the sequence of the traffic light. We're going to go opposite. It's going to go counterclockwise. Instead of going clockwise, we are going from green to red, and then red to yellow, and then yellow to green, okay? So let's take the first case. Going from green to red, yes.
So what you're saying is the way we want to go
As a traffic light.
we want to go as the traffic light, or we want to go as opposite the traffic light.
Opposite of traffic light, we always want to, traffic light is the test first development, that's how it goes.
Okay.
And
then, in the maintenance, you go the other way.
Red, green refactor, remember?
Right.
Red, green refactor, that's like a misnomer. You have two colors, you have red, you have green. Where did this refactor, is that a color, name of a color? Doesn't make sense. That's why the test first development, test first programming, that's why this third color has been introduced. Okay. To make sense, right? For each step what you need to do. The traffic light progression is the right way actually. Everything is going smooth, you're just cruising basically. When you follow the traffic light, everything goes, no accidents happen. Okay, when something is blinking yellow light, you're supposed to stop, look around, and then go. Same thing, you fix your syntax errors, you fix your configuration thing, you have the right library, maybe versioning issue, you fix those things, and then you can proceed. Or red light, flashing red light. Flashing red light is again stop. Right. Look, and then go, you know. Flashing red light is basically, it's giving you feedback. Mm-hmm. You basically use it as a feedback. You should be aware of what these things are. When you're coding, you also need to know what is the right action to take, step to take. Because I've seen a lot of, these concepts are simple to understand. I've seen a lot of very very experienced, talented developers actually staying in red, not because of the exceptional cases where they are doing an upgrade, but they are just taking much bigger steps than required because they're getting overconfident. I can do this, right? It just means when it's red, you need to take smaller steps.
Okay.
Okay. So let's now take a look at the first situation going in the non-traffic direction, going from green to red. You were green and you wrote a test. It just means you did not go through another intermediate thing. It was not yellow for some reason. It just means you did not make any syntax error. Right in the beginning, you will be having all this configuration issues and all those things initially. Once you're set up, once you have some test coverage, you're going to actually build momentum, right? And if you get familiar with the RSpec API, in likelihood you won't make any mistakes most of the time, so you will directly go from green to red, okay? And the test will be failing for the right reason. This is fine. So what about the next situation where you are going from red to yellow? You were red, and instead of actually, think about this for a minute. You were red. The red was because of the right reason you were actually failing, but you went to yellow. So what does this mean? What happened there?
The test.
After red, what do you need to do? It is red. I am failing for the right reason.
Yeah, you fix whatever you did.
Yes,
fix
you
it,
code.
you made a mistake.
You made a syntax mistake in the production code.
Yeah.
You have a mismatching DN block or something is wrong in your production code. So you fix that. This should not happen. If it does happen, you made a syntax mistake, correct it, and you will get back to green. Okay. And the last one you already seen. From yellow to green, that's fine. So writing a failing test. This is going from your yellow. This is making a transition to itself. You made too many syntax. You have a syntax error. You have a configuration error. You make as many one thing at a time, and then once you fixed it, it's failing for the right reason, then you can go to the next step where you're red and you write the production code to go green, okay? And we already discussed about this. You're refactoring and you're green. You have like a pseudo test, 10, 15 tests. Now you're seeing all the duplication emerge. You want to clean up your test, make it more readable. It's green and you end up, you're still green, okay? So here is all the different combinations of what we might have. This is the production code and this is the test code. Okay, the production code is very well designed. The test code is not. The production code is not very well written, but the test code is really written well. This is very difficult to accomplish actually. The test code will always, if you write test after you have written the code, your code, production code actually dictates your testing code, and it makes it very difficult to write clear tests. If your code is nasty, it's very difficult to accomplish this. And obviously we want this. Our objective is to have production code which is good, as well as well-written test code as well. Okay. The fourth case, you could just change your career if this is the case.
Unfortunately, in a lot of the large long-term projects, there's spores usually the case.
Yeah, exactly. You're in this scenario. Either, in real life projects, this is like idealistic way of
you almost never see that.
Yes, almost never seen a real. The bigger the company is,
yeah,
you either are in this situation. The code is nasty, but the test does not exist. The code is nasty, but you need the code, but you need tests for them for your own sake.
Right.
And the organization has a lot of, you need to spend a lot of energy to get this thing into the culture of the company. You are stuck either at this level 2 or level 4, basically. This number 3 is more like a fantasy world, actually. So, quick quiz for you guys. So, what does this flashing yellow light mean?
You still have some kind of syntax error, some kind of configuration.
Either in the production code or in the test code. Could be both. One or the other. And you fix it, and you will go to?
Hopefully red.
Yes. And flashing red light, same thing. Flashing red light, you're just taking much bigger steps than you really need to. So the thing about TDD is, it allows you to, you know how the rock climbers actually climb? It's called 3-point contact, right? They have 4 limbs. Always there is all the 3, only one of your limb is free at a time. And they take very, very small things that they know, okay, I can keep going up. The same thing happens here. Either you work on actually getting a code that works, or you focus on actually refactoring and cleaning up the code. You focus one thing at a time. It's very similar to that, and it allows you to take very small steps when you need to. And if you're confident and everything is going fine, the traffic sequence, the sequence of things is going fine, you can go faster. It doesn't always mean you should triangulate. For instance, there are like 3 different ways to actually solve a problem. One is you just type in a problem is so familiar to you, you just type in the obvious implementation. Other one is fake it till you make it, where you hard code something, and then you make the test force you to abstract the code. And then you can triangulate. The triangulate comes from the mathematical terminology, where you take 2 different measurements, and with 2 different angles, and you measure how far the ship is, and calculate those things. When it comes to TDD, triangulation, basically you have different examples, and you keep make the executable example, and each example will force you to drive out the abstract solution of your eventual, solution to the problem, okay? So now I'm actually going to quickly go over this red-green refactor and just show you how this thing works in practice, right? We just
duplicate, so I'll put that on a stick for you. We'll do that.
So this bowling program is actually from the RSpec homepage. So I start off with a test. The code does not exist yet. Okay, the green. From here, I just start specifying the behavior. I'm describing this bowling, here is the bowling spec. Okay, now what am I actually, where am I right now? I got an error message here.
Looks like a yellow.
So what is it saying? It says uninitialized. I could actually move this a little bit closer to you guys.
Uninitialized constant bowling game.
Yes, so what is it complaining? So is this failing as expected? Is this red or yellow?
Yellow.
Yes, it's more like a syntax. It's not a behavior that is missing. It's more like, yeah, it's you're describing a class which doesn't exist yet, right? So now I'm actually declaring the class that I need. Now I'm green, right? But the test does not exist yet. Now I'm writing a test. This is basically an example of the bowling game, what I expect the bowling game system to behave. So it showed you just a pending example, which was yellow. You haven't done anything yet, okay? And sometimes it just happens you have so many things to do while you're sitting in front of your computer while you're wanting to do these things. You just want to write down, you just make a list of things you want to, you get it out of your mind and put it here in the it's all like pending examples, okay? You can just work through your list one by one.
So what does it mean?
It is basically a method that takes a string, okay, and you actually give the behavior. What's your specifying behavior of the system? What is the feature? And when something happens, you expect something to happen. Okay. This is the behavior of the system I'm describing. I'm describing a bowling game, and I expect this thing to have these two different features or the way it behaves. It could be the same method in this case. Now I'm actually going to write the test. So I told you about 3 A's. The step 1 of the 3 A's is arrange, which you are creating some objects. That's what is going on. You create some object. And then the 2, arrange, act, is where I'm actually doing something there to the system. 20 times game.roll. I'm invoking the method roll on the game object. And the third is the third step that I said, which is assert. I'm asserting what the expected output of rolling the dice 20 times should be. What is the score? What is the expected score? So I'm red right now. The method was not existing. So I'm implementing the method now. Maybe the signature of the method is wrong, so actually fix the signature to take in the parameter. So what's happening here, I just want to stop. You know the role is actually what I'm exercising. So now that's the public API. So you discover, it's a discovery process. What is the API should be. And then I'm calling the score because that's what I expect the score to be something when I have like 10 pins or 12 pins and I miss all of them, the score is going to be 0. So that's how I know I need a score. That's why I'm actually implementing it, because you write code as if it already exists. You write code you wish you had.
Okay.
Okay, you specify, okay, I want this thing to be there, and then you go ahead and implement the method. So you have two examples, one pending. We can make it go a little bit faster.
So, can I ask you a question?
Yes.
Why is it important to just do the minimal amount necessary
That's
to
a
get
very
a taste? Because like putting that 0 in score.
Yes,
like,
yes, yes, very good question.
I never get that.
Very good question. Okay, that's the fake it till you make it. The way I was doing it, the way I solved this problem, returning 0, and then you're returning hard-coded values. But that's not a real solution. That's not going to work for all inputs, right? The reason you're doing it is fake it till you make it is one way to solve the problem. This is helpful when the domain is unfamiliar to you, the problem is not familiar problem. Everybody knows factorial, Fibonacci, those things, right? And you could just type in your obvious implementation the very first time. Obvious implementation, typing in the obvious implementation is one way to solve the problem. If the domain is unknown, it's a very difficult problem, and you haven't encountered the problem before. This fake it till you make it is what allows you to take small steps. It's all about breaking down a big problem into smaller pieces and decomposing the bigger problem into smaller pieces and solving one problem at a time. One example, writing one executable example at a time. Okay, you don't write the very first test to write a very abstract solution that handles all the edge cases, all the corner cases. It allows you to focus. Okay, just because TDD allows you to take baby steps doesn't mean you always need to take baby steps. You can take longer steps if, like I said, it's familiar problem, you already know how it works, you're confident you can go faster. Okay?
So it's just like making the problem more digestible?
Yes, it's making a problem smaller and smaller until you know, oh, I can make this thing pass, I know what to do next. When I showed that video the professor was talking about, if you're just stuck, what do I do next? Sometimes you're stuck, right?
Yeah.
Where were we? Oh, I don't know. What should happen if this thing happens? You're changing the context. You're doing, handling. You may be like, when you're solving a problem, you have so many different things to worry about. But this allows you to focus, okay, this particular scenario, this particular thing, I expect this behavior. You narrow down the SUT, system under test becomes smaller. You always narrow down the SUT to the smallest thing, and you make the test one thing and one thing only. You don't have any overlap between tests. Tests are like isolated and independent of each other. You can run them in any order you want, okay? I'll be going over them in more detail. So that's the answer to your question?
Yep.
So the second one also I'm implementing is kind of like where the first one more question is like, how do you pick the first test to write? What should be the first test you need to pick? If I give you a problem, how do you go about writing the first test?
Well, usually I know the subject that I'm dealing with. So I'm usually given some specification by a project manager that says, I need the system to do this. So I was like, okay, break that down into some architectural diagrams, come up with some method signatures that I know I need to test, and go from there.
Okay, let's say once you decompose the problem, you did a little bit of design, that's okay. You didn't spend a lot of time on upfront design. And you typed in a code like 5 or 10, let's say like
Usually
I did,
class name,
pending
yeah.
a to-do list.
Mm-hmm.
You have 10 tests to write, okay, you're at that stage. Now, how do you go about picking which one of these? Should you go on the first one, second one? How do you know which one to pick at the last one? Which should be the first test to write?
So I mean, I would always start with an interface. So defining my inputs and my outputs or whatever it is that I'm trying to.
Getting close? Close enough?
Start.
This is the very first test, so think a little bit.
seen what happens when you pass null into it, unless you're dealing with small integers and things.
Exactly. Edge cases, because it's very trivial.
Well, everybody.
What does it prove? It just proves you have all the required statements, you have your environment, you have the framework, everything working. Okay, so you test the null case, returning 0, blank string, something which is trivial, which is just a way to get things going. You're trying to build momentum, you're taking your first step.
Well, eventually what this taught me a number of times, someone comes in after my code, passes in null or something, instantiates my class with a null, and the whole system detonates. So, it's like, okay.
Crashes.
Right, yeah. And so, obviously, testing with null the first time around, or null string equivalent.
Yes,
So,
if the class that you are testing is, you are the owner, then you could start with the passing a null pointer exception. If it's some other library, then you should obviously pick a blank string which you know it's not going to crash. The main purpose of the first test, making it trivial, is to get your entire environment, everything set up, so you can keep on moving, gain momentum as you go, write more tests, okay? It also allows, it's basically a learning process. As you start writing tests which is trivial, and then you gradually increase in complexity, you learn more about the domain. You get more confident, and you can actually, it's getting more difficult, you can solve much bigger problems, you get more understanding, better understanding of the system, okay? So, almost okay. I'm going to go faster.
A bit fast, but
Basically, I'm just refactoring the test right now. Okay? The test, everything is the same. When I'm refactoring, I keep all my tests. I have a safety net now. Okay? And I took all this production code, I moved them into a different file. I solved the clean code part later, once I actually solved the real problem at hand. Okay, so almost done. Okay. Now I have this before each and doing all kinds of framework related stuff where I avoid the duplication in the test code, because I want to treat the test code I would treat it production code, right? Because we have to maintain the test code also. And basically this thing is going to, I'm going to evolve the before each. Instead of before each, I'm going to say game, because I don't want to use an instance variable. And then I have this R equals idiom where it's lazily instantiates. If it's already there, I just return the existing instance. And then this is going to evolve into let syntax, where I just say let game be equal to this. And let basically is lazily initializes some variable you want to use. Unless you use that variable, that let block won't get executed. So it's a little bit different from before each. Okay. So that's the end of this TDD demo. The thing I want you to notice though is, what the heck is this 20 times game.roll doing here? This is not, I thought.
Rolling it through 20 times, to executing 20 times.
So why do I care in this? Why should I be caring about rolling 20 times something here in my test? I want to specify behavior, not implementation. So all this if logic, having loops like this in your test is a bad idea. This is not an exemplar code, even though I took it from the RSpec homepage. If this is how you begin your test, your software is going to run faster than you can imagine, actually. And when you write your test, when you write it, Only think about specify behavior. If you specify behavior, you don't think about how of doing something. You only think about what the system should do, right? So let's consider this thing. Let's make this better. This is a bowling game domain. So what am I doing here? I'm getting all zeros in this case scenario. So if, let's say I strike everything, 12, all the 12 pins. It's a strike. In the domain, it's called as a strike because I hit everything. And if you miss everything, probably it's a flop or a miss. So there is a domain-specific term, abstraction missing. Okay, that's miss or strike is what you need to specify here. That is the missing interface you have to discover and implement it in your interface. Because your test should only focus on specifying behavior, not implementation. You have to hide this implementation in your production code behind a well-defined interface. That makes sense for this particular domain, like miss or strike. You may come up with something else for your scenario, okay? So I want to actually give you guys a chance to go through this TDD thing. So let's work out a problem where we have factorial.
It is noon now. Do we want to break and then come back?
Yes, maybe 5-10 minutes break.
Oh, okay. I was saying the thing had a 1 hour lunch break. I was just, what's noon now?
It's 1 now, right?
It's noon now.
Okay.
Or should we?
Okay, it's up to you guys. Whether you want to take a 30-minute lunch break, if you want to grab something to eat here while I actually keep going. So this way you can go home quicker. You know, it's up to you guys. Or you want to take one lunch break.
They want to get their money's worth out of it.
Well, how long is this exercise going to be? I guess will be one of the.
At least half an hour. Okay. The factorial Fibonacci.
Do you want to break up 1? Is that too late?
I can break after this if it's a half hour though. I mean, I drove myself insane with the nested attributes passing arrays back with JSON because having to put all my parameters from the JavaScript side into the right string format, so the variable names automatically file through with 0 code.
Yeah.
It's like, okay, I've got to name it with this, underscore this, and I did all kinds of tests. It took weeks. It was just like, but once you got it, it worked because Rails saw that, turned it into the right data structures, dumped it right through. There was 0 code on the back end. It was all on the weird front end. The nested attributes bit was just mind-bending. But yeah, once it works, it's rather cool how it just...
A little dash instead of an underscore can drive you nuts.
Yeah, I'm trying to think, well, this is an array, it's I got underscore, the element number here, underscore the submodel, underscore this, but not, yeah.
We're almost there, guys.
Yay!
Okay. Actually, I only had 70 slides in my first workshop. This one is like 110. So you guys have been like...
Now, are these slides available for us after this here?
Of course, I can email it to you guys if you want. I can just upload it to the file section. Okay?
Perfect.
So, yeah, one more guy still left. Okay. Any questions so far what you have done? We have like 4 or 5 slides to go through and then we'll work on a kata. I'll give you a kata and USB drive and you can just copy it. And it has a specific instructions, what you should do, the rules.
Okay.
And I will let you work on it and I'll just go on and help you guys to work on it.
Is that the same file that's on GitHub?
TDD kata.txt, you should be able to, so if you go to the meetup.com and you guys were able to connect finally.
I'm using
Shut
it
you
out.
off rather than burn up
I'm
the
using it
battery.
out.
So that, the calculator thing?
Yes, that's right.
Okay.
I put a link to the GitHub gist, right? That's
Yeah.
the right thing.
Yeah.
Okay,
Do you copy of that?
I'll get it in a minute. I just substitute
if you want, we can make it a little bit
HTTPS
closer to you guys. That way you don't have to.
Oh, no, it's okay. I mean, I forgot my glasses, so I need to be closer.
Can you magnify it or it's...
Oh, bring it closer.
Bring it closer. I know this is kind of like very difficult because last time when I was here they had this projector. I was able to use, this time it's not anywhere. Okay, So we already saw this payment strategy and how they are using this in combination with mocks. Okay, the next thing is mix-ins, plugins. How they are using the stubs. One more thing is not just mix-in and plugins. You can also use the stubs to speed up your tests. Actually, nowadays what's happening is, a lot of people are taking all the business logic not just in the model. Initially, it was all about thin controller, fat model. Now the fat model is not fat anymore. All they take the business logic out in its own modules, and you mix them in to your stubs, and you test the behavior that way, actually. So because once you have a module that can be mixed in anywhere, you can just take a stub and then mix it in. Okay. So in this case,
everywhere then.
so in this case, the mix-ins and plugins, we have age identifiable. This is a role, right? When you have a mix-in and plugin, this is very similar to interfaces in Java. So we have a module called age identifiable. So it's a role probably. So it has can vote is one of the method in that interface, and these are the behavior. It raises exception if including does not respond to birthday. Okay. It must supply a birth date, otherwise I cannot determine the user is qualified to can vote method. So you basically create an instance of the object, and you extend with the module that you actually have the behavior, age identifiable. Okay, and this object is nothing but a regular object. It's not really an active record or anything. The same concept can be applied to your active record models. You can just say instead of object, it will be your user or some other active record, and you extend them with age identifiable behavior. And then this expect. This expect basically is a post-condition check in the design by contract terminology. What this does is it takes a block, this code within the block, it gets executed, and it checks after that is executed what's going to happen. So after object can vote is executed, it is expecting to raise error, and that error message is going to have a message must supply a birth date. Okay, so the second case, it returns true if birth date is 18 years ago, because they are valid and they can vote. You create an instance of an object, and you're stubbing that particular object, the birth date method, okay? And the birth date method is stubbed, and the return value is 18 years ago. So that this person is 18 years old. It will respond to birth date. In this case, it will not raise an error or exception. And the can vote method, when you call this, it's actually, you can make this object can vote should be true. You can just make it as object dot, you can even say should be underscore vote, because that's probably, since it's like a can underscore vote, I think this is a better way, that's why these guys have done it this way. Object can vote, question mark, should be true, because yes, they can. You also have to test the negative condition, like you were saying. People always test the golden path. See, the golden path, you don't really test that much at the customer test level, at the cucumber test, cucumber acceptance testing level. But you should test all the negative scenarios, all the alternatives at the unit test level, because it's isolated, it'll run fast, and you need to make sure it can also work in the negative scenarios also. Message expectations, okay, the one more scenario where you can actually use marks is the side effects that we already discussed. Side effect is like this, putting some message into a queue, or sending an email. There is no state change. There's change in the state of the system, but there is a side effect. There is an outgoing message. That's what I mean by side effects when I do this. So statement, we already saw this, I guess.
Yeah.
Okay, those side effects, that's where we use the mark. This is in combination with stub.
And caching, I also mentioned this caching, and don't over-specify when you're using marks, okay? So in this case, it makes sense for me to say, I create a mark, just usual, and then I create the SUT, and then I install this mark at the second statement, zip code equals zip code.new, provide the zip code and the mask, and then I'm setting the expectation. Validator should receive valid with this zip code once and return true. In this case, I'm constraining it once, very specifically, because for caching, it makes sense. I call it once, that's why I'm calling it twice. Zip code.valid, it will receive valid question mark, okay? Second time, when I call zip code.valid, it won't even hit the, it won't hit that method again. It's basically a cached value, so it just returns the value immediately, okay? So we already saw this interface discovery, how in the diagram, we were just going from one object to the next, and then how we replace those objects which doesn't exist yet. But the messages are being sent from one object because that object depends on the services provided by some other object. So the object A's outgoing message becomes an incoming message for the object which is providing that service. So here we are working on something. So it requires that collaboration with some other object. So you create a mark, that's something I need. And something that you're working on is the SUT. So you install this mark using dependency injection as a constructor, pass in this mark, and you set the expectations, should help me. So that help me in red is actually the interface that you have discovered. Okay, that's the interface I need, and the return value should be there, so it needs to return this particular string in this case. So you can also, the thing I'm working on, do something complicated. In this case, do something complicated is the interface of the object thing I'm working on. And I briefly described this different layers here through this diagram. So you have layered, well designed in a system, you have a layered architecture. You have a technical domain. I have shown you several different technical domains like UI, ORM layer, messaging layer, web services layer. All those layers are technical domain layer. You will have very technology specific lingo that you'll be using all this terminology. Has many, for instance, has belongs to, those are relational terminology that you're using in the ORM layer. You don't want them to be actually going into your application domain. So we have adapters, and we isolate those. If you want to upgrade your ORM layer, ideally you don't want that to impact your core domain. This could be your own separate module or a package, and the release cycle for this thing would be different from the release cycle for this. If it's external library, you don't want to be under the mercy of somebody else's, scheduling release, right? So it should not impact your stuff. So we have adapters which convert the concept from this technical specific layer to the concepts to your domain specific layer here. So the UI events going in and out. So this also translation happens here also, okay? And also you don't want to be impacted with the terminology that your web services or your payment gateway provides. They may be calling it something as a payment, you may be calling something as a credit card, but you want to have conceptually, you want to have, you don't want any mismatch basically. You want to stick to a terminology that everybody agrees within the team here. So that you'll have another translation layer. So those are the adapters. That's what this thing shows, and you have the translation here, the window, the table model, table, all those things. Isolate the changes, the impact of changes is minimized. Okay? And I also briefly went over this, why you should not be marking third-party APIs, and having a thin wrapper. In this case, you can see the adapter layer is a thin wrapper. Those interfaces are well-defined interfaces. The application objects are only calling into the adapter layer which we own, and we can mark this adapter layer. Since we own this adapter layer, we can application objects only can talk to those marks, which will be much faster. And anything that goes back and calls back into your application code, in this case, you can mark this because we actually own this. Okay. So in this case, the application objects there is one interface in the adapter layer, which we are actually that particular cluster you can test separately as an integration test, because the adapter layer is eventually going to talk to the third-party API, and that integration test is what is going to give you that confidence. Okay, this will work in the production system because it has to integrate with the external third-party API, right? Anything from the adapter layer that's calling back into your application objects, we are marking it, okay, because we own that. That's it. Now it's time for you guys to do the TDD kata. And already, if you don't have a copy, I can just copy it into my flash drive and you can copy it.